Hello everyone. In this video, we will discuss about silicates. We will discuss what are silicates, what are the different types of silicates, what is the classification of silicates, and what are the different uses of silicates in different areas, and what are the structure of different silicates. Out of all the silicates, only sodium silicates is the only common silicate which is mainly soluble in water. And most of the silicates are insoluble in water. Only we have sodium silicate that is soluble in water. Other silicates are insoluble in water. Why this is happening? This is mainly due to the great strength of silicon oxide bond, and this bond can be broken only on treatment with strong reagents like we have hydrochloric acid, which is the strongest acid known to us. So in presence of this, that acid can break the SiO bond only. That's why only other most of the silicates are insoluble in water, because silicon oxide bond is very strong bond, so that cannot be easily break when it will dissolve in the water. So that's why all silicates are insoluble in water except sodium silicates. As we know that SiO bond, it is having 50% of covalent in character, while 50% in the ionic ring character. So SiO silicon bond is having both covalent as well as ionic character in nature. They have property of both type of covalent as well as ionic compound. And the electronegativity of oxygen is 3.5, while the electronegativity of silicon atom is 1.9. So difference between the two electronegativity of the both the atom, that we are getting 1.6. That's why they are having the, due to this range, they are considering in the category of 50% covalent and 50% of ionic nature. We can say that all the silicates, they are mainly composed of, that is silicate tetrahedral unit, which is the main unit of all the silicates through which they are made up of. And these units are mainly formed by the sp3 hybridization of si orbitals, in which silicon forms the four bonds with the oxygen atoms, as we have seen in the previous slide. Now let us discuss about classification of silicates, how we can classify silicates in different category on the basis of arrangement of silicate units, that is in the tetrahedral form. We can see that the classification of silicate, it depends on how the tetra units are arranged in the silicate molecules. On the basis of that one, we can classify, these are the main class of silicates, in which we have orthosilicates. These are also known as nesosilicates. This is pyrosilicates, ring silicates, chain silicates, sheet silicates, and framework silicates. So these are the different classes of silicates in which we can categorize the silicates on the basis of tetrahedral unit arrangement. Thus, we can see that orthosilicates are those silicates which is mainly consist of one tetrahedral unit, that is silicate unit. And in case of pyrosilicates, these are those silicates which is made up of two tetrahedral units which are bonded to each other, sharing one oxygen common to each other. Ring silicates are those silicates which are mainly made up of 3 to 4 or more than that tetrahedral units, through which they are forming a ring type structure. That's why we are calling the ring silicates. Chain silicates, these are the further classification. And sheet silicates are those silicates in which tetrahedral unit, that is silicate unit, are arranged in the form of sheet type structure. That's why we are calling them sheet silicates. While last one is the framework silicates, in which we can see that tetrahedral units are arranged in the form of three-dimensional structure. Yeah, we can see cross network type structure. That's why they are called as framework silicates. Now let us take one by one of different classes of silicates. So first, silicates are of type of orthosilicates. What are orthosilicates? Basically, the minerals that contains the individual tetrahedral units, that is silicates units, these are referred to as orthosilicates. Yeah, other name for orthosilicates are neosilicates. And this is the naturally occurring earth crust mineral through which it is the structure image of the orthosilicate that we are obtaining from the earth crust, that is called orthosilicate. And this is the octahedral structure of the orthosilicate, in which we are seeing the different atoms are arrangement. This is the single unit of silicate in which silical atom is bonded with the four different oxygen atom. That is the single unit which is mainly responsible for the formation of orthosilicates, in which we can see that silicon oxygen bond length is 162 picometer, while the angle between OSIO, that is the 109 degree point 5 minutes. This is the angle between this one. And this orthosilicates, they have very high densities and high refractive index. Thus, they can be utilized as gemstones in various applications, like we have jewelry purpose, yeah, some other purpose. Examples of gemstones which are categorized in the category of orthosilicates include, that is one of the most common is the topaz, whose formula is Al2SiO4 FOS ka whole twice. Second is the phenacite, which is having the general formula, that is Be2SiO4, and zircon, that is having formula ZrSiO4, garnet, that is having the formula CaAl2SiO3O12. So these are the some of the examples of the gemstones which are mainly included in the category of orthosilicates. And topaz, basically, it is the aluminium silicate fluoride hydroxide. So this is the topaz, as we have seen. This is the formula for topaz. And the structure of topaz is mainly controlled by a chain-like structure of a connected octahedron. As we can see in this case, this is the octahedral structure, which is mainly in case of topaz. These octahedron have an aluminium in the middle, as we can see in this case. This is the aluminium blue color line in the middle, surrounded by the four oxygen. So these are mainly different structure, in which case we can see their oxygen atom is surrounded. Above and below the aluminum are the hydroxides of fluoride. So in this case, we have different atoms are around the aluminum. We have oxygen, hydroxide, and fluoride is also arranged around the surrounded by the this one. And the chains of octahedrons are held together by the individual silicate tetrahedron, but it is the octahedron chains that give the topaz its in crystalline shape, as we can see in this one. These are the images of different precious stones, here we can say gemstones, that can be utilized for various purposes, like we have utilized for astronomy purpose. As we can see, this is the image for the opal, this is for amber, peridot, amethyst, this is the ruby, sapphire, spinel, and this is the topaz, this is the turquoise, citrine, aquamarine, crystal quartz, zircon, turquoise, this is the diamond, and this is the emerald. These are the various precious stones that can be utilized for various purposes. Now let us discuss what are ring silicates. So basically, ring silicates, they contain the SiO3 whole and 2N minus. This is a general formula for the ring silicates ions, which are mainly formed by linking three or more tetrahedral Si4 4 negative units cyclically. We can say that ring silicates are the minerals, yes, silicates, which is mainly made up of three or more tetrahedral units which are joined cyclically. That means they are forming a cyclic ring type of structure by combining with each other. And in this ring silicates, each unit shares two oxygen atoms with other units. As we can see in this case, that this is the structure of Si3O9 6 minus, and this is the structure of Si6O1812 minus. In both the structure, we can see that every unit it is sharing the two oxygen. This is the first oxygen, this is the second, which is shared by the other units. Similarly, if we are considering this unit, so we can show that these are the two oxygen, this first, this second, which are shared by the other. If we are considering the third unit, so that is also sharing the two oxygen, this is first, this second, with the other two units of tetrahedral unit. Similarly, in this case, that is Si6O1812 minus, we can also see that each unit, tetrahedral unit, that is sharing the two oxygen atom with other units present in case of this silicate unit, that is Si6O1812 minus. In this case, we can say these two are common. For this unit, we have these two. For this here, we have these two common. For this tetrahedral, we have these two oxygen atoms. This for this one, we have these two. And for this, we have these two atoms are common for other units. So on the basis of they, because they are forming a cyclic ring, as we can see in this case, this is the cyclic ring. Similarly, they are also forming cyclic ring. So that's why ring silicates are also referred to as cyclic silicates. Examples for ring silicates are benitoite, that is the formula is BATISiO3 ka whole thrice. And one of the common example, most important example of ring silicate is the beryl, that is having chemical formula B3Al2SiO36. And these are some of these minerals that can be also utilized as a gemstones. Now come to the another class of silicates, that is chain silicates, and these chain silicates are also known as inosilicates. And chain silicates are of two types, that is single chain silicates, that are also referred to as pyroxene, and second type is that is double chain silicates. This is also known as amphibole. In this, if we discuss about single chain silicate, this is the structural units, structural formula, and structural diagram for the single chain silicates. In this case, so what are single chain silicates? So chain silicates, yeah, pyroxene that contains the SiO3 and 2N minus ions, which are mainly formed by the linking n number of tetrahedral, that is SiO44 units linearly. As we can see in this diagram, that all SiO4 4 minus units are linearly joined with each other. That's why they are referred to as single chain silicates, because they are forming a single chain. There is no double chain is there, only single chain is present. That's why they are referred to as single chain silicates minerals. In this case, we can see that there are two oxygen atoms per unit tetrahedral are shared to form a single chain, and the mineral pyroxene is formed. In this case, we can see that in this case, if we are considering this tetrahedral unit, because this is the chain is not end here, these two atoms are sharing by the other units. Similarly, if we are considering this tetrahedral, that is Si4 4 minus, these two oxygen atoms are sharing by the other tetrahedral units to form the single chain silicate, that is pyroxene, and the tetrahedrals are arranged in alternate position to left and right along the chain. As we can see that this is left hand side and this is right hand side alternate. So these are present in the alternate manner. However, more complex chains are also be spiral. Examples for single chain silicates are, that is spodumene having formula LiAlSiO3 twice, and deposite, which is having the chemical formula CaMgSiO3 cut twice. If we will discuss about what are double chain silicates, yeah, these are also referred to as amphibole. Then we can discuss that in which two pyroxene chains are joined by sharing another oxygen atom to form a double chain. Then amphibole is formed. As we can see in this case that in this case two pyroxene chains. So this is the first chain, this is the second chain. When they are for sharing another oxygen with the different chain, so they are forming the amphibole. Yeah, we can say double chain silicate types structure. In this case, some tetrahedral units, that is Si44 negative ions, they are sharing two oxygen, while some are sharing the three. As we can see in this case that this tetrahedral unit, it is sharing all the three oxygen with the other tetrahedral unit. This is the first, the second, the third. While if we are considering this tetrahedral unit, it is sharing only two, that is first and second oxygen, which is sharing by the other tetrahedral unit. So in this case, we can say that some tetrahedral units, they are sharing the all the three oxygen atom of tetrahedral units with the other units, while some are sharing only two. Examples for double chain silicates are asbestos, whose chemical formula is Mg3Si2O5OH4; tremalite, that is having chemical formula Ca2MgFe5 Si8O22OH twice, and in which asbestos is the strong and hard but very brittle in nature, and it is the cheap and resistant to heat, acids, and alkalis. However, asbestos thus can cause lung cancer when we are using continuously this. Now let us discuss about another class of silicate minerals, that is called as frame-brush silicates, that is also referred to as tectosilicates, and these are also known as three-dimensional silicates. Here we can say tectosilicate. And the general formula for three-dimensional or tectosilicate is SiO2 ka whole n, in which all the oxygen atoms of SiO4, these are shared with the other tetrahedral units, and thus we can say they are forming the three-dimensional type of network type structure, as we can see in this diagram. In this arrangement, the stoichiometry is reduced to SiO2, which is mainly oftenly called as silica, which is a collection of small piece of quartz is sand. Examples for three-dimensional framework structure is we have quartz, tridymite, and cristobalite. These are the some of the examples of framework silicates, in which we can say that all the oxygen atoms are shared with the other. That's why they are forming the network type of structures. Now discuss about what are the various uses of silicates. So it always depends on their physical properties, where we can utilize the different silicate minerals in different areas. For quartz, if we discuss about quartz, so we can utilize the quartz mineral to make electronic equipment, watches, gems, lenses, etc. While if we discuss about mica, which can be utilized to make electrical insulator in high voltage electrical equipment and in capacity. Similarly, asbestos can be utilized as a heat insulator to make fire retardant coatings. It can be utilized for ceiling sheets, vehicle brake linings, exhaust manifolds, and gaskets, etc. And they can also be utilized in widely in ceramics, cement, and glasses also as a mixture material. Now, at last, discuss about summary of the present video. In this video, we have discussed what are silicates, and we also discussed how we can classify the silicates in different categories, like we have orthosilicates, we have pyrosilicates, we have sheet structure silicates, we have chain silicates, and we have framework silicates type different class. We have also discussed what are the various uses of silicates depending on their physical properties. They can be utilized for various areas. And at last, we have also discussed the structures of different classes of silicates in the present video. These are some of the practice questions that can be utilized, that can be solved by watching this video. As we can see that what are silicates, classify silicates, that is the classification of silicates, write the use of silicates, what is chain silicates, define pyrosilicates, discuss about sheet type silicates. These are some of the references through which we have prepared this video. Thank you for your kind attention.